Hello learners, welcome back to my channel Shraddha's Physics. Today we will discuss Cauchy's inequality. Cauchy's inequality is sometimes called as Cauchy's quasi-inequality. The Cauchy's quasi-inequality states that for an analytic complex function f of z within and on a circle C, if the function, suppose f of z modulus, the modulus of f of z is lesser or equal to m is any number, any value, this m for every z, then the modulus of nth derivative of the function at the point, suppose any point A, the modulus will be lesser or equal to that m into n factorial divided by r power n. Okay. For this r is called the radius of the circle. This r is the radius of the circle, and this is the radius of the circle, and this n is called, you can see I am writing here fna. So, this n is called the order of the derivative. This is the order of the derivative. So, this is the statement. This Cauchy's inequality states that the function should be analytic in nature. The function is a complex function. If this function is analytic and we are defining this as if f of z modulus is lesser or equal to m for every possible values of z, then the nth derivative of the function at any point A, the modulus will be lesser or equal to m n factorial divided by r power n, where this r is the radius of the circle and n is called the order of the derivative, or you can see that here we are going to calculate the nth derivative of that function. Clear? Now, let us prove this. We are going to prove this statement, that is Cauchy's inequality. So, let us consider the Cauchy's integral formula. Just try to write the Cauchy's integral formula. You can write, if you can remember the Cauchy's integral formula for the nth derivative, if I am writing for the nth derivative, then this will be fn of a, this is the nth derivative of the function at the point A, this is equal to n factorial divided by 2 pi I into integration over the contour C, this is f of z divided by z minus a. We are writing previously a as z naught. So, do not get confused, this is your z minus a power n plus 1 dz. So, here this a is a point where the function should be defined. We are going to define the function at the point z equal to a. Okay. Now, if we will consider the modulus of this function, that is fnth of a modulus will be equal to, here I can take the modulus, then this will be like n factorial divided by 2 pi, and if you can remember, the modulus of I is nothing but I into minus iota. This is the complex conjugate of that I into I. So, this will be equal to I square is minus 1 and this is minus 1. So, minus 1 becomes plus 1. So, now for I modulus of I we can write plus 1. Again integration over the closed contour C, the modulus of f of z divided by the modulus of z minus a whole power n plus 1. Clear? Into the modulus of dz. Now, you can see here, if I will consider this f of z modulus is lesser or equal to m, then we are going to prove this. If I will consider this f of z modulus is lesser or equal to any value m, then we will prove that fn, the nth derivative of that function will be lesser or equal to mn factorial divided by r power n. So, here in this place of f of z, you can see here this is f of z and this is f of z modulus, and also this is f of z modulus. So, if I will put this f of z of modulus is lesser or equal to m, so you can see here this equal sign will converted to the lesser equal to sign, since f of z modulus is lesser equal to m, so we can write this as n factorial divided by, this will be lesser equal to n factorial divided by, this is n factorial divided by 2 pi integration over c, this f of z modulus converted to m, this is replaced by m divided by z minus a whole power, the modulus of this power n plus 1 into the modulus of dz. Clear? Now, we can see here this z minus 1 is, z minus a is present here. So, if I will take this z minus a equal to r exponential I theta, so this z minus a, here I am writing z minus a, this is equal to capital R exponential I theta. If you can remember this r, here we have considered that the radius of the circle. So, that the dz will be equal to dA will be goes to 0, that will be equal to iota, the exponential I theta derivative will be iota r exponential I theta into d theta. This is the value of dz. Now, if I will solve for the modulus of dz, this will be equal to iota into minus iota, this will goes to 1, the modulus of iota, here I am taking the total modulus of dz, so that the modulus of iota will be 1 and this r will be remain as it is. Again the exponential I theta conjugate will be exponential minus I theta. So, this will be the modulus of exponential I theta will be exponential I theta into exponential minus I theta. So, during the multiplication the base is same. So, the power will get added exponential I theta minus I theta. So, this will get cancelled, exponential 0 will be equal to 1. So, here this term also vanishes, the only remaining term will be r into d theta. This is the modulus of dz is equal to r into d theta. Now, if I substitute these values here in place of the modulus of dz and the modulus of z minus a here, if I will put this value here for the z minus a modulus, this will be equal to the value of r will remain as it is, exponential I theta will be exponential I theta into exponential minus I theta. So, that goes to 1. So, the modulus of z minus a will be equal to r. Now, let us substitute all these values here. So, this will be the nth derivative of the function a f of n of a, the modulus of it will be lesser equal to, this is n factorial divided by 2 pi into the integration over the contour c, in place of m I am writing m divided by this z minus a modulus is r and the power will be n plus 1, this will be r power n plus 1, this is modulus of n plus 1 or it is same as r power n plus 1 and the modulus of dz is here r d theta. So, this is here I am writing r into d theta. Okay. Now, here you can see that the only variable is d theta. So, this theta now varies from 0 to pi, 0 to 2 pi, because in a circle the angle, the total angle is 0 to 2 pi. Now, we can also write this as, this will be lesser equal to n factorial divided by 2 pi, this m is constant. So, m is here, this r will get cancelled with r power 1. So, the remaining term will be r power n into the integration over d theta over the limit 0 to 2 pi. Clear? Now, also we can write it again. This will be equal to the modulus of fn of a, it will be lesser equal to n factorial divided by 2 pi into m by r power n into the integration for d theta will be theta, and by putting the limiting value upper limit, this will be 2 pi minus the lower limit, that is 0. So, this will be total value will be 2 pi. So, this will be into 2 pi. So, the 2 pi get cancelled, this 2 pi get cancelled. So, the remaining will be the modulus of fn of a will be lesser equal to n factorial into m divided by r power n. So, this is the proof of Cauchy squares inequality. That is, for any complex analytic function f of z, if I will take the modulus of f of z, this is lesser equal to m, any value m, then for that fnth of a modulus will be lesser equal to n factorial m divided by r power n. This is all for today. Thank you.